Good evening. Myself, Dr. J. Jayesh Kumar, Assistant Professor in Chemistry from the Department of H&S. Today, I want to discuss about the topic of polymer materials. And in this, first of all, I want to discuss about the topic of Teflon. Teflon is also known as the polytetrafluoroethylene, and it is obtained by polymerization of water emulsion of tetrafluoroethylene under pressure and in the presence of benzyl peroxide as a catalyst. And these Teflon, which can also be synthesized from the tetrafluoroethylene by the decarboxylation, and the preparation of important addition of polymerization. The Teflon is manufactured by heating a tetrafluoroethane with a free radical or per sulfate catalyst at high pressures, and it is used in making oil, seals, and gastrics, and also used for non-stick surface coated utilities. And this Teflon is chemically inert and resistant to attack by corrosive reagents. Next, the properties of Teflon. The properties of Teflon. The Teflon is having a high softening point, that is the more greater than 350 degrees centigrade, and it has high chemical resistance. The Teflon is a good mechanical and the electrical properties and having a high performance suitable for a polyethylene. And the Teflon is also due to the presence of high electronegativity fluorine in structure of Teflon, strong interchange forces are present, which may it be extremely tough. Next, the uses of Teflon. It is used in insulating motor transformers, and it is also used in making the wires and non-stick cookware coated are made up from Teflon. For example, the uh, firing pan. And next, it is also used for making a gastrics, tank leaking pipes and tubes for chemical industries. And it is also used for making a non-lubricating bearings. And Teflon is one of the lowest coefficients of friction against any solid. Lowest against solid. And next, we can discuss about the PVC. First of all, what is meant by PVC? PVC is nothing but the polyvinyl chloride. So polyvinyl chloride is a versatile thermoplastic material obtained from the ethylene and the vinyl chloride polymerization. And it is the one of the best explored material in the world due to the serious scientific researches carried in order to disprove the associations. And this polyvinyl chloride, which can also be synthesized from the vinyl chloride. And this polyvinyl chloride is a vinyl polymer constructed of repeating a vinyl groups, ethanyls having one of their hydrogens replaced with a chloride groups. And it is also obtained by heating a water emulsion of vinyl chlorides in presence of benzyl peroxide or hydrogen peroxide in an autoclave under a high pressure. Next, here we can discuss about the synthesis of polyvinyl chloride. These polyvinyl chloride, which can also synthesize from the vinyl chloride in the presence of benzyl peroxide at the heating of 30 to 80 degrees of temperature. And next, this vinyl chloride it can also be synthesized from the acetylene when acetylene is reacted with the hydrochloric acid in the presence of metal oxide at 60 to 80 degrees to form a vinyl chloride. Next, we can discuss about the synthesis of polyvinyl chloride is first of all the commercially polymerization of PVC is done by free radical catalyst employing a suspension and the emulsion techniques. And second one, the suspension and emulsion techniques are most commonly used in industries. About 80% of production involves suspension polymerization. Next, the emulsion polymerization accounts for about the 12% and the bulk polymerization accounts for these two for a 8%. Next, the synthesis of PVC, first the raw material of VCM, vinyl chloromethane, is pressurized and liquefied and then fed into the polymerization reactor, which contains water and the suspended agents. And through the high-speed ionization within the reactor, small droplets of VCMs are obtained. Next, the initiator is fed into the reactor. Next, PVC is produced by the reaction under a few bar at 40 degrees to 60 degrees centigrade. And this PVC is obtained through the suspension of polymerization is suspended in water as a particle of 50 to 20 microliter, 50 to 200 microliter meters. Therefore, the slurry discharged from the polymerization reactor is stripped of residual of monomer dehydration and the particle size is controlled by the screening to yield PVC in the form of white powder. Next, structure and the properties of PVC. It is a linear polymer and the thermoplastic in nature, and it is a very wide, brittle, solid, hard, rigid material which a characteristics of tender sticker metallic surface. And it also contains the 56.8 percentage of chlorine constant, and it is insoluble in all the hydrocarbon solvents. And the PVC is a pure solvent for the PVC like a cyclohexane and the tetrahydrofluorine. The polymer as produced commercially in the amorphous in nature. It has a melting point of 212 degrees centigrade. Next, the applications of PVC. There are two types of PVCs, rigid and the flexible. The rigid PVC, it exhibits a high surface strength and very a good rigidity. And it is used mainly for the pipes and the windows. Okay. Next of the plasticide PVC. It is used in the manufacturing of films, expanded products, sheets, jacketings for electrical cables, etc. And in packaging, the in food stuff and the pharmaceutical. And in cars, the polymers were used for car doors, dashboards, and the electrical cabinets and the matting. And in electricity and the electronics, jacketing of electricity cables for domestic use, the PVC is used. Next, applications of PVC. The PVC has been used as a construction product for half a century, and unplasticized PVC is one of the stiffest polymer at normal temperature and shows the little dehydration after many years in service. Next, the PVC is a flexible, is used to make the storage bags and in fact, only the material approved by the European pharmacos. And the PVC is also other healthcare product for PVC, and there are the artificial skin, blood transformation sets, and the blood vessels for artificial kidneys. Next, PVC was first used as a in electronic cables, used as a cable insulator as a replacement for a rubber during the Second World War. And in the PVC cable do not harden and crack over time and find use in many applications from telecommunications to electric blankets. And these cables are recyclable by recovinyl. Next, the properties of polyvinyl chloride, PVC. First of all, the PVC is a weathering stability, and the PVC is a resistive to aggressive the environmental factors, is therefore the material of choice for roofing. Second property, versatility. PVC can be a flexible and the rigid. Third one, fire protection. PVC is a material resistance to ignition due to its chlorine constant. And the next, the energy recovery. PVC has high thermal power when utilized in creation. PVC provides power and heat for home and the industry. And the barriers properties. The PVC can be made impervious to liquid and the vapors. Next, uses of PVC. The third most widely produced plastic is unplasticized PVC and plasticized PVC. The unplasticized PVC is highly rigid but brittle for making a sheets, tank leaking, helmets, mud guards, etc. And whereas the plasticide PVC, by adding the plasticide example, the phthalates making the continuous sheets of wearing a thickness, hoses, pipes, construction, table covers, etc. Next, we can discuss about the polystyrene. The material of polystyrene, basic materials for the production of polystyrene. Basic stuff for the production of polystyrene is the benzene and the ethylene. Benzene and the ethylene. Okay, this polystyrene, which can be synthesized from the benzene, is reacted with the ethylene, then it generates to form the polystyrene. Polystyrene. Next, the history of polystyrene. The polystyrene was discovered in 1839 by the scientist Simon from Berlin, and in 1866, Marcelin correctly identified the formation of metastyrol styroxy from styrol as a polymerization process, and the crystal structure of isostatic polystyrene was reported by the Yiguan Nata. Next, polystyrene is actually an aromatic polymer that is made from the monomer styrene. It is also a long hydrogen carbon chain that has a phenyl group attached to every carbon atom. The styrene is an aromatic monomer commercially manufactured from the petroleum. Next, the polystyrene is a vinyl polymer manufactured from the styrene monomer by free radical of vinyl polymerization. Next, the properties of polystyrene. Polystyrene is generally flexible and can come in the form of a moldable solid or a viscous liquids. And the force of attraction in polystyrene is mainly due to the short range van der Waals attraction between the chains. Next, the uses of polystyrene. The outside housing of the computer, housing of the most kitchen applicants, model cars, and etc. are made from the polystyrene, and it is also made in the form of an form that is used for packaging and insulating. The polystyrene is also a generally a flexible and can come in the form of a moldable solids or a viscous liquids. Next, the applications of polystyrene. The application of polystyrene, we can discuss about the household and the automotive. Whereas in household, the power boxes, combs, toys, and bangles, ball pens, water bottles, etc., are can be made from the polystyrene. And whereas the in automotive, the reflector, doom light, display size, and the automatic panel covers, these are the can be made from the polystyrenes of the polymer. Next, Bakelite. First of all, the word Bakelite, which can be named from the scientist as a Bakelite in the year of 1909. And this Bakelite, which can be synthesized from a phenol as the formaldehyde in the presence of acid or the alkali. And the Bakelite, a phenol formaldehyde polymer, was the first composite synthetic plastic made by the Leo Bakelite in 1907. And this Bakelite and his assistant started his their research in 1904 looking for a synthetic sustainable for shellac, and the Bakelite was commercially introduced in 1909, and this used to make billiard balls, but later was used to make molded insulators, insulation, valve parts, knobs, buttons, knife, etc. for the radio and the electronic instruments and more. And next, we can discuss about the preparation of Bakelite or synthesis of Bakelite. First of all, the phenol when reacted with the formaldehyde, it generates to form the orthohydroxymethanol phenol plus para-hydroxymethanol phenol. Okay. Next, this orthohydroxymethanol phenol, 2 moles of orthohydroxymethanol phenol, which undergoes the polymerization in the presence of 2n minus 1 H2O, it generates to form a novolacc by the loss of hydrogen on the alcohol by the elimination of hydrogen and the methyl alcohol. Okay. Next, the novolacc, when the novolacc is reacted with the formaldehyde, when the novolacc is reacted with the formaldehyde in the presence of copolymerization, copolymerization by the elimination of 2n minus 1 of H2O molecule, it generates to form a bakelite as as uh, especially this bakelite, which can be synthesized in 3 steps. First of all, the bakelite, when the phenol is reacted with the salicylic, it generates to form the synthesis of mono or di or a trisubstitute of methanol methanol phenol means based on the ratio of 1 is to 1, 1 is to 2, and 1 is to 3. And second stage, the mono di trisubstitute of the methanol methanol phenol methanol phenol is generated to is heated to synthesize the two resins A and B. First of all, the resin A, which can be formed when the orthohydroxymethanol phenol is reacted with the another mole of orthohydroxymethanol phenol, and by the elimination of 2 moles of H2O molecule, it generates to form a resin A. And secondly, when the uh, methanol phenol is reacted with the another methanol phenol, here the loss of H2O, it generates to form a resin B. And in second stage, In third stage, the when the resin A and the B are, are heated, the finally it generates to form a product as a Bakelite. Next, properties of Bakelite. Here, the phenolic resin to rigid a hard, scorch resistant, inflammable, water resistant, insoluble solids which are resistant to non-oxidizing acids, salts, and many organic solvents, but are attacked by alkali on the presence of free hydroxyl groups in their structures. They possess the excellent electrical insulating characters, and the preparation of bakelite is the phenol formaldehyde polymer are the oldest synthetic polymers. These are the obtained by the condensation reaction of the phenol with formaldehyde in the presence of either an acid or a base catalyst. The reaction starts with the initiation formation of ortho and or when the para-hydroxymethylphenol derivatives, which further react with phenol to form the compounds having rings joined to each other through CH2 groups. The initial product could be a linear product called as a novalet user in paints. Next, uses of Bakelite. The Bakelite, due to its high resistance to electricity and the heat, is used in automatic components and the industrial applications. And due to its excellent insulation of properties, it is used for making switches and other electrical applications. And the bakelite is also used to make the various various kitchenware products like frying pans, etc. And now we can also discuss about the difference between the PVC, polyvinyl chloride, and the polystyrene and the Teflon. Here, the polyvinyl chloride it is a colorless, non-inflammable, and it is having a high melting point of 158 degrees centigrade, and its specific gravity is 2.33 grams per cubic centimeters. And if the polyvinyl chloride is used for the preparation or for making the manufacturing of helmets, refrigerators, and etc. Okay. Next, properties and the uses of polystyrene. The polystyrene is a lightweight polymer which can be used for the preparation of parts of refrigerator, TV, and etc. And it has a less boil melting point, 90 to 100 degrees of centigrade. Okay. Next, uses of Teflon. Teflon is a lightweight and it is a chain polymerization, and it can be used for the synthesis and used for the preparation for making a pipes. Uh, pipes. Okay. Next, the PVC is having the 40 degrees to 60 degrees centigrade, and there are therefore the sluggish discharge for the polymerization is triple for the monomer dehydration. Okay, the polymer of PVC can also be done for the free radical catalyst, implying the bulk suspension. Next, when we go for the Teflon, this Teflon, which can also be known as the tetrafluoroethylene, and this tetrafluoroethylene, which can be synthesized from the uh, decarboxylation of tetrafluoroethylene. Okay, and it is having the high softening of a boiling point greater than the 350 degrees centigrade, and it has a high chemical resistance as well as a good mechanical and the electrical insulator, whereas the PVC is having a good electrical insulator. Next, we go for the synthesis here, which can also the PVC can also be can synthesize from the vinyl chloride in the presence of benzyl peroxide, and this vinyl chloride, which can also be synthesized from the acetylene when reacted with the HCl in the presence of 60 to when heated to 60 to 80 degrees in the presence of metal oxide. Next, structure and the properties of PVC. It is a linear polymer and the thermoplastic in nature, and it is a wide brittle solid, hard, rigid material, and it also contains 56.8% of chlorine constant, and it is insoluble in all the hydrocarbon solvents, and PVC like cyclohexane and the tetrahydrofuran is a pure solvent, and the polymer as produced commercially is amorphous in nature, and it has a melting point of 212 degrees centigrade, and the Tg of the PVC is 80 degrees of Celsius. Next, the two types of PVC are there. One is the rigid and the flexibility. The rigid PVC is it exhibits the high surface strength and the very good rigidity, and whereas the plasticide PVC is used for the manufacturing of the films, expanded products, and sheets, jacketing for the electrical cables, and etc. And in building and the construction of PVC, the PVC windows and the doors of frames are the slaters, finding about drinking water, distribution, flooring, etc. And in packaging, in food, stuff, and pharmaceutical, and in cars, the PVC will occur in the panel for the car doors, dash doors, and the electrical cabinets and the mattings. Next, and we can observe the PVC in electricity and electronics, such as cables for domestic uses, insulation on electrical cables, telephone, and the sockets. Next, the applications of PVC. PVC can be used as the construction product for the half of the century, and unplasticized PVC is one of the stiffest polymers at normal temperature and shows the little dehydration after many years of the service. Next, we go for the polystyrene. This polystyrene which can also be synthesized from the styrene, and the styrene which can the ethylene when reacted with the benzene. Ethylene when reacted with the benzene in the presence of aluminum trichloride, it generates to form a polystyrene. The properties of polystyrene. Polystyrene is a generally flexible and can come in form of moldable solids or a viscous liquids. And the force of attraction in polystyrene is mainly due to a strong short range van der Waals attraction between the chains, and the polystyrene is a generally a flexible and can come in the form of moldable solids or a viscous liquid, and it is also made in the form of foams that is used for the packaging and the insulating, and it is twice molded parts in cars are made in the format. Thank you. This is the topic for today's.